Okay, methods of proof. So a few examples here showing different types of proof. Firstly, one that looks at a method of proof called exhaustion, which means go through every possibility to prove something is always true. We're going to prove for all square numbers they're either going to be a multiple of 4 or a multiple of 1 more than 4. Or 1 more than a multiple of 4, I should say. Now, what we're going to do is prove it's true for all numbers. So I'm going to split all numbers into odd and even. So let's just imagine for even numbers first. Now, an even number is of the form 2n. That must be an even number, because if you multiply something by 2, it has to be even. Now, if I square that, because it's prove all square numbers, then that's going to be 4n squared, which is 4 times n squared, which is obviously a multiple of 4. Because something times by 4 must be a multiple of 4. Now let's look at odd numbers. Now if that always gives you an even number, 2n plus 1 will always give you an odd number. So if we square that, that gives us 4n squared plus 4n plus 1. Now that's equal to 4 times n squared plus n plus 1. So that's a multiple of 4. So all of that is 1 more than a multiple of 4. So for all numbers, odd and even, comprises of all numbers, a square number is going to be either a multiple of 4 or 1 more than a multiple of 4. Example 13, proof by counterexample. This is it can be quite easy to prove something isn't true, because you just give an example of where it isn't true. So prove the following is not true. The sum of 2 consecutive prime numbers is always even. So for example, I don't know, square numbers, 16 plus the sum of 2 consecutive, so 4 and 5, 16 plus 25, 4 squared and 5 squared is 41. Well, that's certainly not even, that's odd. 2 and, I'm doing square numbers bizarrely, so ignore that. So the 2 consecutive prime numbers, so prime numbers, so 7 plus, what's the next prime number after 7 is 11, 18, so that's even. So it is even, so it doesn't, that's not a counterexample. What about 13 plus 17 is 30, so that's even. What about 2, next prime number is 3, is 5, which is odd. So it doesn't matter how long it would take to get there. I've given an example there where 2 consecutive prime numbers is not even, which proves by counterexample that's not true. Example 14. If x and y are both positive, prove that x over y plus y over x must be bigger than or equal to 2. This is an example of one where you're going to find it very difficult to do this if you haven't already seen the solution or something similar to it. So this is where I was coming back to when I was saying that you really need to practice all of these proof questions so you're familiar with them and have seen something similar when you come to the exam. So to prove this, I'm going to start off by looking at x take away y squared. Okay. Now I know that must be greater than or equal to 0. Has to be, because when you square something, it has to be greater than or equal to 0. Now if I expand that out, I get x squared minus 2xy plus y squared. That also must be greater than 0, because that's just the bracket expanded. Now, because x and y are both positive, I can divide both sides by xy. And because they're both positive, that won't affect the inequality. Because you can treat inequalities as an equation, with the exception if you times or divide by a negative. If you times or divide by a negative, the inequality reverses. But because x is positive and y is positive, xy must be positive. So you can divide both sides by xy without reversing the inequality. But why are we doing that? Okay, well, if I now divide each of those by xy separately, we get x squared over xy which is x over y. 2xy over xy is just minus 2. Y squared over xy is y over x. And now I can take the minus 2 to the other side, giving x over y plus y over x must be greater than or equal to 2. B, give a counterexample when it isn't true if x and y are not both positive. Well, for example, we'll just give an example. Say when x equals minus 3 and y equals 6, then x over y is minus 3 over 6. Y over x is 6 over minus 3. So that's going to be minus a half plus minus 2, which is minus 2.5. Well, clearly that's not bigger than 2. Which proves what we're trying to do. Proves that it's not always positive. It's not always true if x and y are not both positive. Okay, that completes the chapter. So we go exercise 7e, then the next exercise. I would advise you to do every single question, checking the answers carefully.